I'm Mohammed Raza from Cox Communication. All I want to ask you is you guys better pay attention because this will be the best session of the whole day. So anybody who doesn't know Cox, we're the third largest cable operator in the U.S. We have around roughly 6 million subscribers. We offer video, internet, and telephone service to our customers. And just like every other service provider, our goal is to provide value-added services to our subscribers that are not only reliable but also cost-effective at the same time. And we want to keep up abreast with the technology like our competitors. So last year, we took on an initiative to deploy live video to iPads, basically to unmanaged devices. So it was a national lineup to begin with, 30 to 35 channels nationally. It is not because we couldn't add more channels. It was because those are the only channels we could get rights from the content providers. As we get more rights, we're going to expand the channel lineup to complete lineup. So it's depending upon whatever we get licenses for. It was restricted to in-home delivery of the content. Again, it is not restricted because of technology. That's the only thing we could get agreements for from the content provider, that whenever we deliver video, we have to treat that as a secondary outlet. So it's a physical device even though it's a Wi-Fi enabled device. So we had to tie it to a home cable modem. We started with the iPad and iPad 2, iPad 1 and iPad 2. We have Droids, Android versions, and PC and Macs in the work. So the the initial launch, we launched it in December 1st of last year. And within the first 4 months, we had 250,000 downloads. And so far, it's been a very successful service. The only major feedback we get is people want to have more content. There is no other feedback. The main one is we want more channels. So before we deployed something like this, it was something that Cox had never done before. So it required a transcoding infrastructure, segmentation infrastructure, DRM application, and also a content delivery network to deliver this video on our network, which is pure unicast because all the MSOs are used to a broadcast, multicast model where the pipe is managed. You don't deliver managed device like this content to unmanaged devices, which would be iPad in this case. So we looked at 3 major things in terms of when we were looking at the CDN infrastructure, how and which vendor to choose and how we go about deploying a CDN in our network. So the main thing we look for was this solution, whatever we choose to deploy, has to be scalable and modular. What I mean by is that if I buy a solution from a vendor X, and if I want to add a feature, let's say video on demand, I don't want to go next year, rip out the whole infrastructure, or add another set of infrastructure just for video on demand. Same thing for federation. If I want to do federation, or if I want to do transparent caching, I want to build a foundation that is very solid. So if I want to add something, I should be able to have hooks already in place so I can just do addition of different services that we want to add. Because these things have to return the revenue we invest in it. The second thing we looked at was the total cost of ownership, not only in terms of how much I'm spending, but also in terms of how much I'm spending on support, upgrade, management, licensing, and things like that. So we looked at how good the actual technical team of that vendor is, how capable they are, how good their staff is, how soon they can offer their SLAs, how easy it is to manage these devices remotely, hardware availability in terms of are they appliance-based or not, because we don't want to be stuck into a separate or a very well-defined hardware platform, because some of the providers, they are Dell shops, some of them are HP, so we wanted that flexibility. So even if you are a appliance-based technology, we want the flexibility to deploy our own hardware if we wanted to, because that's what we have teams trained for, so that we have trained staff who understands HP gear or Dell. In terms of upgrade and downgrade, we want the flexibility to make sure that we can upgrade this system or downgrade this system without affecting the service. Since these are serving the live customers, we want to make sure that when we do have maintenance issues or needs arise, we can do the maintenance while we don't affect the service. And the biggest one that we get feedback from our sites or locations is the power and rack space. So whenever we go and say, oh, I have to bring a 10 RU server and install it in your site, and they can say, all right, I don't have the space. I don't have the power. So we wanted something that was very lightweight and didn't require so much power. And the last but not least, it was the most important, should be the first one. The technology itself, how new the technology is in terms of scalability. So if I deploy a cached solution that is licensed for, let's say, 2 terabytes, when I need it, can it really deliver that performance? And also how, in terms of throughput and latency, how it can deliver the content which is live without significant caching in the network. And I will talk about the flexible URL tokenization and how we utilize it. There are a lot of people who would argue against that. Why did you do a URL tokenization? But we'll have reasons, good reasons why we do it, and the actual component virtualization. So I can have a same hardware and I can virtualize different components of the same platform. So having said that, I'm going to hand it off to Larry, and he's going to talk about Verivue in general.
So thank you. So Verivue, just a quick introduction. We sell various solutions in the CDN space. And one of the key foundations of what we do is to put together a solution that can be extended in many different ways over time, because we do understand that your needs are going to go from live to video to video on demand, to over the top, to edge acceleration, and so on. And so the approach that we take is that we have a portfolio of components or services that can be combined in different ways to solve different problems. So in the case of the live video, which was the initial offering out of Cox, that was relevant to the HyperCache, that's the core caching technology, and the request router, which is how we redirect subscribers to the closest and the best edge cache. The analytics, which I'm not going to spend a lot of time on, but is critically important to the management and overall management of the system. But there's other components that have not yet been deployed within Cox that will, we believe, address problems that will be encountered eventually. And this set, of course, is growing over time. And one of the things I want you to take away from just my description of the underlying technology is you have a suite of components. And in fact, the way that we deploy those components is on a virtualized platform. So each one of those components will run in its own virtual machine at the edge. So if you think about what a virtual machine technology gives you in the cloud, take the data center model of the world where services are deployed in virtual machines, and now put that at the edge cache, at the edge of your network. And now, the same as back in the data center, I can bring up and I can take down, spin up and spin down request routers and caches and request interceptors as my load changes, as workload dictates. And so what we have deployed is running in a virtualized environment. So what I'm going to do just for a couple of minutes is drill down a little bit on one of the more critical of these services or components, which is the HyperCache, the caching technology. And I wanted to hit a couple of key points there. The first one is about scalability. You have limited rack space, and so whether you're putting 1U, 2U, or 10U, you want to get 1U, 2U, 10U's worth of scalable performance. You don't want performance to peak out, and you don't want to have to put the highest in possible to get the performance. You'd like to be able to put commodity one-blade servers in here as one of your options and scale those up. And so the caching solution that we have is completely scalable. And the way you think about it is for however many U's of servers you put in, each one of those nodes is contributing to a site-wide common store. And so we use consistent hashing within that grouping of that cluster to give you a site-wide store. But each one of those nodes can independently serve some set of end users, which is the way this picture is supposed to indicate. Any one user is going to be connected to one front end, but by connecting to that front end, you now have access to the scalable storage. And the way you get performance out of that is by striping, basically, the content across all of those nodes, so that, in fact, when you pull down a large asset, you're pulling down chunks that are being served by individual nodes. You can almost think of it as RAID-like in the way the content is striped across all of the nodes. It's going to give you automatic load balancing that comes from consistent hashing. It's not because we put a heavy cost load balancer in front of it. You're going to get better cache hit rate, and most importantly, you're going to get scalable performance. Cut through routing, I'm going to talk about in a little bit more detail, but that's a critical aspect of delivering live. You have to have very low latency. One other aspect of this particular design for the cache is that should one of the nodes fail, you haven't lost your entire site. You've just lost 1/nth of the capacity of that site. And you will get the consistent hashing algorithm will automatically fail over and pick a different node, and you'll then start serving that. You'll have to reload the content that was lost from that node, but only those chunks will have to be pulled down, and you lose 1/nth of your capacity, not all of your capacity. So that's just a high-level overview of the scalable caching aspect. This next slide, I think, is probably one of the more important ones, which is when we're thinking about live, you might think, well, why do I need to cache live content? It's just flowing through the network. And in fact, I know how to do that with multicast. Well, what I'd like to impress upon you is that you should think of a caching hierarchy as just like multicast, except it has the additional advantage of content can be stored at any one of those intermediate nodes and served in 30 minutes or served in 24 hours as users do time shifting. So instead of pushing content down a multicast tree and saving the bandwidth over a unicast solution, you're literally doing HTTP gets up the multicast tree to the source of the data, and you just pull it down, and as it visits each node as it comes down the caching hierarchy, it's cached there as well as forwarded. Well, the key is, of course, that you get very low latency at each one of these caches, because if it's going to take me seconds to pull it into a cache and turn around and deliver it to the next downstream cache, then that's not going to be a very effective solution in the case of live content in particular. But by optimizing with cut-through forwarding through each one of these proxies, you're able to get that delay or that latency on a per-cache basis down to sub-10 millisecond neighborhood. And so it is as effective to pull content through a caching hierarchy as it is to push it through a multicast tree. And in the process, you've got a very simple signaling protocol. It's HTTP GET is what tells the caching hierarchy that someone is here and wants to pull this content down. So it's much simpler from an overhead point of view, and you get the advantage of caching the data in root. So even though it's live data, it's being pulled through a caching hierarchy. And at this point, I think I'm going to turn it back over to Mohammed to talk about how that solution was deployed.
Yep. To reinforce Larry's point, the way Cox deployed the CDN was we have 5 geographically dispersed sites, redundant clusters of caching nodes. 3 of them on a flat network, and 2 of them are using caching hierarchy, meaning they have a second tier of caching. Because the reason why we did that, because we want to take the traffic off of the backbone. We don't want all these 5 caches go to the central origin and replicate the traffic 5 times, which we can only do it 3 times. I mean, we are doing 3 times for load balancing reasons anyways, but we don't have to. They are geo-redundant request routers, and the first implementation of this delivery was only HLS with 4-second chunks. We are going to 5 seconds because of to make sure we align with add insertion boundaries when we start doing add insertions, because of pre-rolls of 30 seconds and 15 seconds post-roll. So 5-second chunks really align with those. And the URL tokenization. So how do we leverage the CDN infrastructure for our benefit? Basically, the first one was the cut-through. Because of the cut-through and the hierarchy, we get the benefits of multicast, or the benefits similar to multicast on our backbone. Because as soon as we have the second layer, it doesn't have to go all the way to the source to retrieve the content. It basically treats the upper layer cache as the origin. So as we deploy these caches through to 2 layers, 3 layers, or 4 layers down, we will really see the benefits out of it. And it will really take off the burden from the backbone, which makes our backbone guys happy. URL tokenization. The reason why we do it is to discourage few people to initiate denial of service attacks on the downstream. So we make sure the client who's making the request is a valid client from our network. And we do that based on quite a few variables that we put in the tokenization schema, like IP addresses, UDID of the devices, and the MD5 hash. If the consumer who's making the request matches that hash that has been generated for that client, we allow that delivery. Otherwise, we do not deliver content just because you ask for it. So you want to make sure you are a valid customer who's asking the information. If you are the valid customer, we'll deliver the content. So that's how we validate you as a consumer as well. This is not to say that you can get the content and still watch video. Video itself is encrypted. You still need the decryption and the DRM keys to decrypt and view that content. But this is just to protect the network itself. And in the URL itself, we put custom tags like IP addresses, the device type itself, and your hashed account number, if we have to put it, which in an anonymized way, so it is not personally identifiable. But at the same time, we can leverage URL tokenization for reporting and usage analytics. So adding to that previous bullet, basically we use CDN as a bandwidth management. We want to understand how our network is being utilized in terms of peak concurrency, how many concurrent users we have, what kind of video bitrate a consumer is watching. If I'm delivering you 3 profiles, highest, low, and the lowest, we want to know who is getting the lowest profile and why is he getting the lowest profile. Is there congestion in the HFC? Is there congestion on the backbone? And CDN monitoring and CDN analytics combined with the reporting done by all the schemas and things that we put in the URL tokens, we can leverage all of that, and we can do reporting network-wise. So there's a school of thought. Somebody would say, you shouldn't do network-based reporting, and some would say, oh, client-based reporting is the best approach. We think that Cox thinks that the best way to do it is to do as much reporting and analytics you can do in the network. So when you deploy different device types, Android, PCs, Macs, you don't have to worry about what client consumer has or whether my reporting tool or reporting appliance that I ported to the client, is it really compatible with that client or not? If I'm doing in the network, combine that with a very good data warehousing scheme, you can slice and dice that data any way you want it. You can go 6 months back. You can do all the trending. That client-based reporting tool will never give you that. Before we close out, right now, as I said, we started with linear, but we are thinking of doing video on demand. Things that are on the horizon we want to leverage, and there's a good business opportunity to use these caches in universities, military bases, and campuses that have very dense population, but they don't have a very expensive uplink. So we want to offer video services, but they don't have a 5 gig link up. So we want to deploy caches deep into their network, and this is something we're exploring, and I think there's a good use case for that. Transparent caching and federation, we are still watching it cautiously. We don't know how it is going to pan out, but we're keeping that in mind. Having said that, I'm going to stop talking and open the floor, I guess.
I think we have a couple minutes for questions before we move on. In the back.
DRM, has this ever come across as a requirement for the data that you're delivering?
Yeah. Because we have to make sure that the content is not only encrypted, but we also have to make sure if you're delivering video to the iPad, you disable certain output controls. So like we have to disable AirPlay and things like that. And copy freely, we probably will set a copy none.
What kind of solution do you use with
We have NDS. Yeah.
You have known about the case where the channel streams are transported to multiple data streams.
Right.
And is this happening within the network, or is this basically policy one provider?
Yeah, so the question was, where do we do the transcoding of the content? So it is Cox managed content. So we have a national infrastructure where we ingest content and we transcode it into multiple profiles. We segment it nationally, and we also DRM and encrypt it nationally before we deliver the national. Once we deploy a local content, we will do the local processing at the local site of all that content before we post it to the CDN. Yep.
Is there any technology overlap yet between the content delivery of legacy form-based videos and the new IP videos?
Yeah. So you want to answer that? Yeah, legacy assisted one?
You know it better.
So yeah, we are looking into the to also leverage the same CDN for legacy assisted VOD, but there's not been a business case yet. But we are looking into it.
So we do have other deployments where it's video, it's CDN assisted VOD. So it's traditional cable head end CDN and even traditional streamers to set-top boxes at the other end, but the same CDN in the middle.
Yeah, so the solution that we have deployed is the Apple HLS. So it is the client itself does the adaptive implementation. So what we have seen so far in our network is that our network has not been the point of contention, or even the modem itself is usually the person who is using the Wi-Fi router. He is way out, probably at the porch or something, and that's when the actual client sees that I don't have enough throughput, and he scales down. And when you come up, it actually scales up. As long as we get the rights from the content owners, we are ready to do off-net. I mean, the solution is ready to deliver off-net content.
Yeah, cool.
Just a question. What do you guys see as some of the barriers to adopting
HD and SD content?
Yeah, like you were carrying on
Yeah, I don't see there's much of a challenge because it is managed content. So we are the ones who actually ingest it and process it in terms of MPEG-2. So right now we generate only one profile, which is MPEG-2 transport stream for our set-top boxes, for example. What we'll have to do, we'll have to add transcoding gear to transform that into a different adaptive profiles for iPads or the Droids. It's not a. There is no issue other than money and technology, right? And the content rights, obviously.
Yeah. Minor detail.
Right. Yeah.
So, one more?
Yes. The reason why we didn't deploy a 1 second chunk is because there's so much unicast traffic, because every chunk that you request, you go back to the CDN. So we wanted to make sure that the transactions per second to the CDN is minimized. The reason why we only use 4 seconds is because we saw that in terms of channel change and acquisition, it was faster instead of ingesting the whole 10-second chunk. Yeah. Not yet. There is no policy-based routing or policy-based engine right now, but there will be some in the future to monitor in-home traffic and also access traffic.
No one's telling us to pass it down here, but I'm starting to feel a little guilty about
Sure.
hogging the time. We'll be available to continue discussion.